Question 1. A technician, Mr. Alvarez, is called to a residence where the homeowner reports a strong odor near the boiler. The technician performs a combustion analysis and finds high levels of carbon monoxide in the flue gases, despite the burner flame appearing blue and steady. The draft is within specifications and no visible soot is present. What is the most likely cause of the elevated readings? A. Excess primary air creating incomplete mixing in the burner. 2. B. Insufficient combustion air due to a tightly sealed mechanical room. C. Undersized gas orifice causing poor atomization. D. Improper manifold pressure from the gas valve. Answer. Correct answer. B. Explanation. High levels with a stable flame and no visible soot often indicate oxygen-starved combustion, typically caused by inadequate combustion air, especially in sealed or mechanically ventilated spaces, while other issues can cause NFPA 54 and ANSI 0.1 emphasize ensuring combustion air volume is sufficient. Even with draft in spec, lack of oxygen impairs complete combustion. Excess air would lower not increase it. An incorrect orifice size or manifold pressure usually causes erratic flame or other symptoms. Question 2. A multi-zone commercial office building utilizes a two-pipe direct return system. The building engineer notes that zones farthest from the boiler are consistently colder than those closest. Which factor is most likely contributing to this imbalance? A. Insufficient pump head for the longest piping run. B. Undersized boiler unable to meet the full heating demand. C. Airlock in the distant zones due to poor purging. D. Lack of circuit balancing valves in the direct return configuration. Answer. Correct answer. D. Explanation. In direct return systems, water tends to take the path of least resistance, favoring closer zones without balancing valves. Farthest loops receive less flow, causing uneven heating. This is a design consideration addressed in ASHRAE guidelines and hydronic textbooks. Pump head would affect all zones, not just the far ones. Boiler capacity and airlocks could contribute, but uneven heating from distance is most closely to lack of balance in flow regulation. Question 3. Is Hartley installs a condensing gas boiler in a residential radiant floor heating system. 2 weeks later, the customer complains of fluctuating heat output and high energy bills. The technician finds the boiler operating with a return water temperature of 150°. What adjustment would most effectively restore optimal efficiency? A. Lowering the outdoor reset curve to reduce water temperature. B. Increasing the pump speed to improve GPM. C. Replacing the expansion tank to prevent pressure surges. D. Reducing boiler firing rate to limit short cycling. Answer. Correct answer. A. Explanation. Condensing boilers reach peak efficiency when return temperatures are below 130°, allowing condensation of flue gases. Return temp of 150° prevents this, lowering the outdoor reset curve aligns supply temperature with actual heating load, reducing return temps. Increasing flow does not guarantee low return temps if the load doesn't absorb more heat, expansion tanks and firing. Adjustments may solve other problems but won't directly address condensing efficiency. See ARI and manufacturer specs for condensing efficiency guidelines. Question 4. A technician is performing a boiler startup on a new installation using LP gas. After verifying manifold pressure and spark ignition, he notices delayed ignition accompanied by a loud whoosh sound. What is the most appropriate next step? A. Reduce the manifold pressure to decrease flame instability. B. Verify ignition electrode gap and burner alignment. C. Add more primary air to improve air-fuel mixture. D. Replace the gas valve as it is likely defective. Answer. Correct answer. B. Explanation. A delayed ignition with a whoosh suggests ignition occurs after unburned gas has accumulated. This is commonly due to poor spark positioning or inaccurate electrode gap, not necessarily pressure or air issues. NFPA 54 and manufacturer instructions emphasize proper burner and ignition system configuration. Adjusting manifold pressure without cause may violate spec, and replacing the gas valve without diagnostic confirmation is unwarranted. Question 5. During seasonal startup, Istabat purges air from a hydronic system and notices gurgling noises persist in several zones. He installed automatic air vent on the supply head-on, a microbubble air separator. What is the most likely reason for the persistent air issues? A. Air separator installed on the return side instead of the supply. B. System pressure too high for air to separate effectively. C. Air vent caps left closed during operation. D. Undersized expansion tank causing entrained air. Answer. Correct answer. A. Explanation. Air separators are most effective at the hottest point, just after the boiler on the supply side, where microbubbles expand. Installing it on the return side lowers separation efficiency. Per Caliphate and Bell and Gossett technical manuals, this is frequent air. Pressure too high can limit air venting, but not air collection. Closed vent caps would stop air removal, but not allow gurgling after purging. Expansion tanks, pressure, not air separation directly. Question 6. A ski lodge in a remote location uses a glycol-based hydronic system for snow melt. Technician Mr. Stevens measures glycol concentration at 30% and finds fluid cloudy with a sweet odor. What action is most appropriate? A. Flush and replace with fresh 50% glycol solution and inhibitor. B. Increase expansion tank pressure to accommodate higher viscosity. C. Install an inline strainer to remove glycol breakdown products. D. Add a corrosion inhibitor to restore pH balance. Answer. Correct answer. A. Explanation. Glycol degrades over time, losing freeze protection and forming acidic byproducts. Cloudiness and odor suggest chemical breakdown. The only safe, co-compliant remedy per APD standards and major glycol suppliers is to flush and replace with a properly mixed solution, typically 50% for freeze protection in extreme conditions. Expansion tanks and strainers help system mechanics but do not address chemical degradation of fluid. Question 7. Why is it required to include both a high-limit aquastat and a low-water tefillur and a residential gas boiler? To satisfy redundancy in compliance with NFPA 31 and ASME CS01. B. To avoid false shutdowns during warm weather. C. To ensure maximum efficiency in modulating systems. D. To regulate burner firing cycles. Answer. Correct answer. A. Explanation. The high-limit aquastat protects against overheating, while a low prevents dry firing, which can lead to catastrophic failure. Both are required by ASME CS01 and referenced INFPA 31 and manufacturer installation manuals. These safeties are independent and serve unique functions. Efficiency and cycling regulation are secondary considerations and managed by other controls. Question 8. Izzy Amada is troubleshooting a 3-zone system where Zone 2's thermostat calls for heat but the circulator never energizes. All wiring appears correct and 24V is present at the transformer. What should she check next? A. Verify the end switch in the Zone 2 valve is closing. B. Replace the thermostat as it might be defective. C. Check boiler aquastat for high limit lockout. D. Inspect the circulator motor windings for shorts. Answer. Correct answer. A. Explanation. In zoning systems using zone valves, the thermostat opens the valve and the end switch then signals the boiler or circulator. If the valve opens but end switch fails, the call doesn't trigger the pump. This is the next logical test after confirming wiring and voltage. Thermostats rarely fail without total loss of function. Aquastat and circulator motor checks are later steps unless broader symptoms appear. Reference Honeywell zoning schematics and Toku valve manuals. Question 9. Condensing boiler with a modulating gas valve frequently cycles between high and low fire. Mr. Rojas suspects the boiler is oversized. Which system behavior best supports his conclusion? A. Short firing durations with high return water temperatures. B. Continuous high fire operation during peak demand. C. Condensate drain rate increases during firing. D. Flame signal readings fluctuate during modulation. Answer. Correct answer. A. Explanation. An oversized boiler satisfies demand quickly, leading to short cycles and elevated return temps, preventing condensing and reducing efficiency. This cycling is often seen in modulating systems with inadequate turn-down ratios. Continuous high fire implies proper sizing. Condensate rate and flame signal are normal variations and not diagnostic of oversizing. Refer to a CAM Manual S and Boiler Sizing Guide. Question 10. Technician performing combustion analysis on a gas-fired atmospheric boiler records 9.0% CO and 30 ppm CO in the flue gases. The flame appears stable and blue. What is the most accurate assessment of this reading? A. Combustion is efficient and within acceptable limits. B. Primary air needs adjustment to reduce CO further. C. CO levels are too high and indicate incomplete combustion. D. Boiler is overfired and needs manifold pressure reduced. Answer. Correct answer. A. Explanation. A CO level around 9% with CO below 100 ppm typically indicates efficient combustion. Most manufacturers consider 100 ppm CO acceptable. Blue flame and stable combustion confirm it. Adjusting primary air may degrade flame. CO of 30 ppm does not suggest overfiring. Refer to ANSI 0.1 and manufacturer combustion specs. Question 11. Mr. Patel notices his newly installed outdoor reset control is not effectively reducing the boiler supply water temperature during mild weather. The outdoor sensor is mounted on a north-facing wall shaded and away from direct sunlight. The system frequently cycles on and off. What is the most likely cause of the issue? A. The outdoor sensor placement results in inaccurate ambient temperature readings. B. The reset curve is set too low for the building's heat loss. C. The boiler's high limit acrostat is overriding the reset control. D. The circulator pump speed is set too high, causing short cycling. Answer. Correct answer. A. Explanation. Outdoor reset controls depend on accurate outside temperature sensing to adjust supply temperature. Placing the sensor in shaded or inconsistent locations, north side sheltered, can cause incorrect data, making the system think it's colder outside than it is, preventing proper reset. This is outlined in typical hydronic control installation guidelines such as those from Tocco or Honeywell. Reset curve and pump speed influence performance but not cause poor temperature sensing. High limit acrostats protect temperature but don't affect sensor input. Question 12. As Nguyen finds the expansion tank appears fully charged and the system's pressure relief valve is intact and not leaking. What is the most probable cause of the ongoing pressure drop? A. Hidden leak in the system piping or heat emitters. B. Overcharging the expansion tank with nitrogen gas. C. Malfunctioning pressure-reducing valve causing water loss. D. Improper boiler fill procedure leaving trapped air pockets. Answer. Correct answer. C. Explanation. In sealed systems, pressure-reducing valves control fill water. A malfunctioning valve may leak small amounts continuously, causing pressure loss, while leaks and trapped air can cause pressure issues. Leaks usually manifest with visible water or damp spots, and air causes erratic pressure, not sustained drops. Overcharging expansion tanks usually leads to high pressure, not loss. NFPA 211 and ASM CS01 highlight importance of proper pressure-reducing valve function. Question 13. Mr. Garcia is installing a gas-fired boiler in a small utility room with no windows and a single door. Which is the best method to ensure proper combustion air supply according to code? A. Installing a dedicated duct from the outdoors to the combustion air inlet of the boiler. B. Opening the door periodically to allow fresh air entry. C. Relying on natural infiltration through door undercuts. D. Using a mechanical exhaust fan to increase room ventilation. Answer. Correct answer. A. Explanation. According to NFPA 54 and International Mechanical Code Inc., confined spaces must have dedicated combustion air sources, such as ducts from outdoors, to supply adequate oxygen safely. Opening doors or relying on infiltration is insufficient and unsafe. Mechanical exhaust without makeup air worsens the problem by depressurizing the space. Proper combustion air prevents incomplete combustion and co-hazards. Question 14. Simmons notes some radiators are hot while others remain cold despite thermostatic radiator valve ERVS ing fully open. The system uses a variable speed pump controlled by a differential pressure sensor. What is the most plausible cause of the problem? A. The variable speed pump is not maintaining sufficient flow at low demand. B. Incorrect installation of IVS causing hydraulic imbalance. C. Excessive air trapped in the system piping. D. Expansion tank pressure is too high, restricting flow. Answer. Correct answer. B. Explanation. RVS must be installed correctly, return side with proper orientation to maintain hydraulic balance. Improper installation can cause uneven flow regardless of pump operation. Variable speed pumps adapt to demand, but if valves cause hydraulic lock, flow to some radiators is restricted. Air causes noise and reduced heat, but not selective cold radiators. Expansion tank pressure affects system pressure, but not selective valve function. Refer to ERV manufacturer installation instructions and hydronic balancing standards ASHRAE. Question 15. Mr. Thompson is inspecting a gas boiler with a standing pilot ignition system. He notices that buildup around the pilot assembly and the flame sometimes flickers. What is the best corrective action? A. Clean the pilot orifice and check for proper gas pressure. B. Replace the standing pilot with an intermittent electronic ignition. C. Adjust the combustion air dampers to increase airflow. D. Install a larger gas valve to increase fuel delivery. Answer. Correct answer. A. Explanation. Certain flickering pilot flames indicate incomplete combustion or blockage. Cleaning the orifice and verifying gas pressure is the first and safest step, as dirt or debris can restrict gas flow. Replacement with electronic ignition might improve efficiency, but is not necessary if pilot issues can be resolved. Adjusting dampers or valve size without diagnostics can worsen combustion. NFPA 54 and manufacturer instructions guide maintenance of ignition systems. Question 16. A homeowner with a primary-secondary piping system complains of high noise levels near the boiler. Mr. Lewis, the technician, suspects pump operation issues. Which scenario best explains the noise? A. The primary pump is oversized, causing excessive flow velocity in the primary loop. B. The secondary pumps are too small, causing cavitation at zone valves. C. The expansion tank is waterlogged, increasing system pressure noise. D. Air vents are blocked, allowing air accumulation near the pumps. Answer. Correct answer. A. Explanation. Oversized pumps increase velocity and turbulence, causing noise and vibration, especially in the primary loop where flow is constant. Proper pump sizing per manufacturer curves, Bell and Gossett, Taco is crucial. Small pumps cause flow problems, but not typically cavitation at valves. Waterlogged expansion tanks affect pressure, but not pump noise. Blocked air vents cause gurgling, but less often pump noise. Question 17. During a retrofit, Mr. Franklin notices a gas piping run uses black steel pipe for the gas supply and galvanized steel pipe near the boiler. What is the correct action based on code requirements? A. Replace galvanized steel with black steel or approved piping before connection to the gas appliance. B. Coat galvanized steel with anti-corrosion paint and leave in place. C. Wrap galvanized pipe with insulation to prevent moisture damage. D. No action required if the pipe shows no visible rust. Answer. Correct answer. A. Explanation. Galvanized steel is prohibited for gas piping inside buildings because zinc coating can flake and clog appliance orifices and it reacts with gas components. Code C. G. NFPA 54 and local plumbing codes require use of black steel or approved piping for gas lines feeding appliances. Painting or insulation does not mitigate hazards. Visible condition is irrelevant to code compliance. Question 18. Is Lopez observes a hydronic system pressure fluctuating daily with no visible leaks and finds the pressure-reducing valve recently replaced. The system has a bladder-type expansion tank installed vertically. What should she check next? A. Confirm the expansion tank pre-charge pressure matches system static pressure. B. Replace the pressure relief valve to restore proper pressure control. C. Remove air vents to prevent pressure loss. D. Increase pump speed to maintain steady pressure. Answer. Correct answer. A. Explanation. An incorrectly pre-charged bladder tank causes pressure fluctuations as the bladder overexpands or collapses improperly. The pre-charge should equal system static pressure, usually 1215 psi residential. Pressure relief valves vent water to relieve overpressure but do not cause fluctuation unless leaking. Air vents remove air, not water. Pump speed affects flow, not static pressure. Question 19. Mr. Evans installs a boiler rated at 150% of the calculated heat loss for the building, citing future expansion. After the first winter, the system frequently cycles on high fire with short off times. What negative consequences is Mr. Evans likely experiencing? A. Increased wear on burner components and reduced efficiency due to short cycling. B. Higher fuel consumption but better comfort due to rapid heat delivery. C. Low return water temperature leading to improved condensing. D. Increased water pressure causing frequent pressure relief valve activation. Answer. Correct answer. A. Explanation. Oversized boilers cycle frequently, causing premature wear, and efficient fuel use and poor comfort. Controlled rapid cycling prevents stable return temps needed for condensing efficiency and stresses controls. While higher consumption occurs, it is wasteful, not beneficial. Return temperature and system pressure effects depend on other factors, not size alone. Refer to CAM Manual S and boiler manufacturer guidelines. Question 20. Mr. Chang installs a new forced draft gas boiler but uses vent piping that is one size smaller than specified. What issues is this likely to cause? A. Increased draft leading to flame instability and potential safety hazards. B. Reduced draft causing flue gas spillage and incomplete combustion. C. No impact as long as the vent is properly sealed and terminated outdoors. D. Excessive condensation within the vent pipe causing corrosion. Answer. Correct answer. B. Explanation. Undersized vent pipes restrict flue gas flow, reducing draft, causing incomplete combustion and possible backdrafting of hazardous gases. Codes such as IMCA manufacturer manuals specify vent sizes to ensure proper draft. Excessive draft is rare in forced draft systems. Proper sealing alone does not mitigate undersizing risks. Condensation depends on pipe material and temperature, not size. Question 21. Mr. Ortiz measures the manifold pressure on a natural gas boiler during operation and notes it drops significantly below the manufacturer's specification during burner firing. What is the most likely cause of this pressure drop? A. Undersized gas piping feeding the boiler. B. Excessive primary air supplied to the burner. C. Clogged condensate drain causing back pressure. D. High static pressure in the combustion area inlet duct. Answer. Correct answer. A. Explanation. Undersized gas piping causes a drop in gas pressure during high demand, leading to flame instability and poor combustion. NFPA 54 and manufacturer guidelines emphasize proper sizing to maintain consistent manifold pressure. Primary air affects combustion but not gas pressure. Condensate drains impact water removal, not gas supply. Combustion air pressure influences air-fuel mixing, not gas manifold pressure. Question 22. Carver installs a new closed-loop hydronic system without an expansion tank. Shortly after startup, the system pressure relief valve discharges water frequently. What explains this behavior? A. Thermal expansion causes water volume increase without room to expand, triggering relief. B. The boiler's high limit echostat is set too low, causing pressure spikes. C. Air trapped in the system causes pressure surges. D. The circulator pump is creating excessive system pressure. Answer. Correct answer. A. Explanation. Water expands as it heats, increasing volume in a closed system. Without an expansion tank to absorb this increase, pressure rises sharply, activating the relief valve. ASM CSO1 and Hydronics design standards mandate expansion tanks to maintain safe pressure. High limit echostats control temperature, not pressure. Air can cause noise, but rarely sustained pressure relief. Pumps do not generate pressure beyond system head. Question 23. Mr. Jackson replaces an old standing pilot with an intermittent pilot ignition system. After installation, he notices the boiler sometimes fails to ignite on the first try, causing multiple ignition attempts. What is the best troubleshooting step? A. Check and clean the flame sensor for proper detection. B. Adjust gas manifold pressure to increase pilot gas flow. C. Replace the spark module to ensure adequate spark duration. D. Increase primary air to enhance pilot flame stability. Answer. Correct answer. A. Explanation. Flame sensors detect pilot flame. A dirt or misalignment causes failure to register, resulting in repeated ignition attempts. Cleaning and repositioning the sensor is the first step at NFPA 54 and manufacturer service manuals. Adjusting gas pressure or spark modules is secondary. Increasing primary air affects flame characteristics but not sensor detection. Question 24. Is Ramirez fills a new hydronic system but fails to remove all air from the piping. After startup, several zones experience cold spots and gurgling noises. She installed manual air vents on radiators but no automatic vents on the main supply header. What is the best corrective action? A. Install and maintain automatic air vents at high points in the system to continuously remove air. B. Increase system pressure to force air out through manual vents. C. Open radiator valves fully to flush out trapped air. D. Drain and refill the system with a higher fill rate to minimize air pockets. Answer. Correct answer. A. Explanation. Automatic air vents continuously release entrapped air from system high points, preventing accumulation that manual vents alone cannot efficiently address. This is recommended by Bell and Gossett and Calafi for system reliability and noise reduction. Increasing pressure or fill rate risks damage. Opening valves may help temporarily but won't solve trapped air long term. Question 25. Istising observes that a circulator pump runs but no water flows through the system. The pump shaft spins freely and power supply is verified. What is the most likely cause? A. The pump impeller is clogged or damaged, preventing water movement. B. The expansion tank is waterlogged, restricting flow. C. The zone valves are closed, blocking flow to the system. D. The pressure relief valve is open, causing a system leak. Answer. Correct answer. C. Explanation. Closed zone valves prevent flow despite pump operation. Confirming valve position is a basic and critical step in troubleshooting. Impeller damage usually results in noise or vibration, but a free spinning shaft suggests mechanical failure or open system. Expansion tanks don't block flow. Pressure relief valves open cause leaks, but wouldn't stop flow entirely unless catastrophic. Question 26. Is Chen's two-pipe reverse return hydronic system uses zone valves controlled by thermostats. During mild day, one zone cycles rapidly on and off, while others run steadily. What is the most plausible explanation? A. The zone thermostat is oversized or has an incorrect differential setting, causing short cycling. B. The zone valve is failing to fully open, restricting flow. C. The pump speed is set too high for the system design. D. The boiler high limit is shutting down the burner intermittently. Answer. Correct answer. A. Explanation. Oversized thermostats or narrow differential settings cause rapid cycling, leading to wear and discomfort. Proper thermostat selection and settings per industry best practices prevent short cycling. Valve failure causes lack of heat, not cycling. Pump speed affects flow but not zone control cycling. High limit prevents overheating but would affect the entire system. Question 27. Mr. Lopez installs a gas-fired boiler in a utility room with combustible storage nearby. According to safety codes, what must he ensure? A. Maintain minimum clearances between the boiler and combustible materials as specified by NFPA 31. B. Install a code detector inside the boiler room to monitor emissions. C. Use only PVC vent piping for safe venting of combustion gases. D. Remove all storage items regardless of clearance to eliminate fire hazard. Answer. Correct answer. A. Explanation. NFPA 31 mandates minimum clearances to combustibles to prevent fire hazards. Installing code detectors is good practice but not a substitute for clearance. PVC vent piping is generally not approved for gas boilers except in specific condensing applications per. Removing all storage is ideal but not always feasible. Adherence to clearance rules is essential. Question 20. Is Edwards performs initial commissioning of a newly installed forced draft boiler. She notes the draft gauge reading is lower than specified despite proper vent installation. What should she check next? A. The combustion air intake for blockages or restrictions. B. The gas pressure regulator for overpressure conditions. C. The fuel type to confirm compatibility with the boiler. D. The condition of the heat exchanger for fouling. Answer. Correct answer. A. Explanation. Insufficient combustion air causes low draft as the burner cannot draw enough air. Blockages or closed dampers are common issues. Gas pressure regulators affect fuel delivery, not draft directly. Fuel compatibility is critical but unrelated to draft gauge readings. Fouled heat exchangers affect heat transfer, not draft pressure. Question 29. Mr. Fernandez is selecting a glycol solution for a hydronic system in a commercial building located in a cold climate. He opts for a 20% glycol concentration based on freeze protection charts. After installation, some heat emitters report inadequate heat output. What is the likely cause? A. The low glycol concentration increases fluid viscosity, reducing flow and heat transfer. B. The pump speed is insufficient to overcome glycol's higher viscosity at 20%. C. The glycol solution concentration is too low to provide freeze protection. D. Glycol reduces the fluid's specific heat capacity, requiring higher flow rates. Answer. Correct answer. D. Explanation. Glycol solutions reduce specific heat capacity compared to pure water, meaning more fluid volume or flow is required to transfer the same heat, while viscosity also increases. 20% glycol typically balances freeze protection and flow. Low concentration affects freeze point, not viscosity, drastically. Pump speed can be adjusted, but the root cause is reduced heat capacity necessitating system compensation. Question 30. Its core notices some baseboard heaters in a one-pipe hydronic system are hotter than others, causing uneven heating. What is the most effective method to improve heat distribution? A. Install flow balancing valves or orifice plates on each baseboard circuit. B. Increase pump head to force more flow to cooler zones. C. A second circulator pump dedicated to cooler zones. D. Reduce the boiler temperature to lower heat in hotter zones. Answer. Correct answer. A. Explanation. One-pipe systems inherently have flow imbalances due to pressure drop. Installing balancing valves or orifices on circuits regulates flow, equalizing heat output. Increasing pump head generally increases flow overall, not balance. Adding pumps complicates control. Reducing boiler temperature affects overall output, but not individual circuit balance. Refer to hydronic balancing standards Ashry, Bell, and Gossett.